Hello students, welcome back. Let's continue with chapter 4, that is linear equations in two variables, and today's topic would be solution of linear equation in two variables. Here are the solved examples in your book. However, before I proceed further, let's just quickly revise linear equations in single variables. So let's say if I say x plus 3 is equal to 0. Here x will be equal to 0 minus 3, therefore x is equal to minus 3. So I just got one solution for my x. If I take another variable, say y is equal to minus 8. Again, you cannot solve this further, so there is one single solution for this expression. For single variable, linear equation in single variable. If I take something like 3x is equal to 4, what do I get? X is equal to 4 upon 3. So do you notice one thing, that linear equations in single variables are just going to give you one and only one solution for your variable, which can be plotted on a number line. So there exists only one unique solution for linear equations in single variables. Now we'll check for linear equations in two variables. So let's say I take something like 2x plus 3y is equal to 6. Now a very simple way to find the value of your variables is just to substitute the value of x as 0 once and the value of y as 0 once. So if you substitute the value of x as 0 once, you will get the value of y, and if you substitute the value of y is equal to 0 as once, you will get the value of x. So let's check 2x plus, let's say I substitute x is equal to 0 in the first instance. What do I get? 2 into 0 plus 3y is equal to 6. So this is going to be 0 plus 3y is equal to 6, which is nothing but 3y is equal to 6 and y is equal to 6 upon 3, which is 6, 3 ones are 3, 3 twos are 6. So y is equal to 2. Y is equal to 2 when x is equal to 0, right? So my solution would be, one solution would be 0 comma 2. Now let's substitute x is equal to 0 and y is equal to 2 in this, on the left hand side of this equation, and you will notice that the answer is 6. Let's check. I am substituting for 2x plus 3y. So the value of x is 0 plus 3 into 2. It gives me 0 plus 6, which is nothing but 6, which is equal to the right hand side. Now another thing, now I substitute x as 0. Let's substitute y as 0 and find out. So I'll say 2x plus, so here my solution was, I'll write the solutions on top. I had 0 comma 2. Okay, 2x plus 3 into 0 is equal to 6. So what do I get? 2x plus 0 is equal to 6, which is nothing but 2x is equal to 6, which means x is equal to 6 upon 2. So therefore 2 ones are 2, 2 threes are 6. So x is equal to 3 when y is equal to 0. So what is your solution in this case? It's 3 comma 0, right? So we have another solution, 3 comma 0. Let's check for other variables. If you take any value, any integer or any real number, let's say I take something like 2 into, let's say I take the value of x is equal to 2. So what do I get? 2 into 2 plus 3y is equal to 6. Therefore 4 plus 3y is equal to 6. Therefore 3y is equal to 6 minus 4. Therefore 3y is equal to 2 and y is equal to 2 upon 3. So one more solution that we got is 2 comma 2 upon 3. Let's take another. Now I'll take a value for y, just any random value. Let's say I take a negative integer now. I'll say y is equal to minus 5. So what do I get? 2x plus 3 into minus 5 is equal to 6. So what is this going to be? 2x is minus 15 is equal to 6. 2x is equal to 6 plus 15. So 2x is equal to 21 and x is equal to 21 upon 2. So what is the solution that we got? 21 upon 2, always the value of your x first and then y. So 21 upon 2 minus 5. I'm just taking any random value, just considering one random value and finding the value of another variable. So one such solution that we got here is 2 comma 2 upon 3 and 21 upon 2 comma minus 5. Let's check for some rational number. So if I take something like x is equal to 1 upon 2, what do I get? 2 into 1 upon 2 plus 3y is equal to 6. So 2 ones are 2, 2 ones are 2. I get 1 plus 3y is equal to 6. Therefore 3y is equal to 6 minus 1. Therefore 3y is equal to 5. Y is equal to 5 upon 3. So another solution that we got was 1 upon 2 and 5 upon 3. So you can just keep going on by taking any random values, assume any random value for one variable, and you will find the value of another variable when a linear equation has been given. So from this we conclude that there exist infinite solutions of to the linear equations in two variables. Okay, so I'll write this down. There exist infinite. The word infinite is very important here. In fact, I think in the introductory session we also learned where I was just giving you an overview of the entire chapter. I did mention that there exist multiple solutions to linear equations in two variables. So here we have finally concluded the multiple could be infinite also. In some cases in the exercise you will notice that there exists sometimes only two solutions or maybe one solution, but usually it is multiple solutions or infinite solutions to linear equations. I'm just abbreviating linear equations to LE in two variables. So please take a look. Now we'll go ahead and solve the examples in your textbooks, which are on page 69. So I'm erasing this section of the board. So the first one, find 4 different solutions of the equation x plus 2y is equal to 6. I'll just write my question. X plus 2y is equal to 6. So the best way to start with is just consider any one of the variable as 0 and you will find the value of another variable, and vice versa. You consider suppose you are considering in the first case as x is equal to 0, the second case you consider y is equal to 0. So you will at least get 2 solutions, and the other solutions we will go by trial and error, just like we did in the previous sums that we solved here, right? So I will take for x is equal to 0, what do I get? 0 plus 2y is equal to 6. Therefore 2y is equal to 6. Therefore y is equal to 6 upon 2 and y is equal to 3. How 3? 2 ones are 2, 2 threes are 6. So one of our solutions is 0 comma 3, right? For y is equal to 0, what does the equation become? X plus 2 into 0 is equal to 6, which is x plus 0 is equal to 6. Therefore x is equal to 6, right? So what is the solution in this case? 6 comma 0. Let's consider any other random value. Again for x, I'll say let x be equal to 1, or I'll say let x be equal to 2. So I get 2 plus 2y is equal to 6. So this will be 2y is equal to 6 minus 2, y is equal to 2y is equal to 4, y is equal to 4 upon 2. So 2 ones are 2, 2 twos are 4. For y is equal to 2. So for x is equal to 2, y is equal to 2. So what are my solutions? 2 comma 2. Let's take another random value for y. Since we took for x, we will take a value for y. For y is equal to, let's say, let's take y is equal to 2. Oh, we already have y is equal to 2, so I'll take y is equal to 3. So what does my equation becomes? X plus 2 into 3 is equal to 6. We have y is equal to 3, so I'll take y is equal to 4 because we already have one solution, y is equal to 3, so no point taking it as. You can take something like y is equal to 1, so I get x plus 2 into 1, so x plus 2 is equal to 6. So x is equal to 6 minus 2, therefore x is equal to 4. So what is the solution that we have? We have 4, 1. You can take any negative value also. For example, instead of y is equal to 1, if I would have taken y is equal to minus 1, let's see what our equation becomes. X plus 2 minus plus 2 into minus 1 is 6. So x minus 2 is equal to 6. So x is equal to 2 plus 6 plus 2 or 2 plus 6. Therefore x is equal to 8. So one of our solutions could be 8 comma minus 1. Isn't that pretty simple? So you can take any random value and you will, for one variable, and you will find the value of another variable, and thereby you will find the solution. This 6, okay, this is 6, right? So with this we have solved the first question. So you can just mention that this point, this pair, this pair, this pair, this pair and this pair are the solutions to your linear equation in two variables. For your question number 1, you could pick any 4 that you want, or you may try your own set of numbers for the variables. So let's go ahead and solve the second question. So find 2 solutions for each of the following. For each of the following you just have to find 2 solutions. The previous one we needed 4, now we just need 2. So let's take the first one. I have 4x plus 3y is equal to 12. So the very first thing that you're going to do is you're going to consider the value of x is 0, because that's the simplest way for finding solutions now. So for x is equal to 0, what do I get? 4 into 0 is plus 3 into y is 12. Therefore 0 plus 3y is equal to 12. Therefore 3y is equal to 12. Therefore y is equal to 12 upon 3. So 3 1s are 3, 3 4s are 12. Y is equal to 4. Right. So what is your solution? One of your solution is 0, 4. Right. I'll box it up. Let's take y is equal to 0 now. For y is equal to 0, what do I get? 4x plus 3 into 0 is equal to 12. So 4x plus 0 is equal to 12. Therefore 4x is equal to 12. Therefore x is equal to 12 upon 4. So 4 1s are 4, 4 3s are 12. Here x is equal to 3. So what is your solution? It is 3, 0. Hence we have found 2 solutions. I'll write the answer over here. My 2 solutions are 0, 4 and 3, 0. Pretty simple. Let's go ahead with the second one. You have 2x plus 5y is equal to 0. So I'll write my question. 2x plus 5y is equal to 0. Again I'm going to do the same thing, or since we already know by substituting x is equal to 0 and y is equal to 0, we are definitely going to find the variables, but let's go ahead and try something different. So I'll say for x is equal to 1, what do I get? 2 into 1 plus 5y is equal to 0. Therefore 2 plus 5y is equal to 0. Now 2 is going to come on my right hand side, so it will become negative. Therefore 5y is equal to minus 2. Therefore y is equal to minus 2 upon 5. Right. So what's my solution? It is 1, minus 2 upon 5. Let's take a value for y. So I have for, let's say y is equal to 1. What do I get? 2x plus 5 into 1 is equal to 0. Therefore 2x plus 5 is equal to 0. Therefore 2x is equal to minus 5 and x is equal to minus 5 upon 2. So what's my solution in this case? Minus 5 upon 2, always the value of x first and then y. Minus 5 upon 2 comma 1. So I'll just write the answer over here. We have two solutions, 1 comma minus 2 upon 5 and minus 5 upon 2 and 1. This is 5, right? So I'll erase this board now, this section of the board, so that we can do the third question. I hope you followed what we did until so far. So 3y plus 4 is equal to 0. Now this looks like an equation in one variable. So let's convert this to an equation in two variables. How are we going to do that? I'll say solution 3y plus 4 is equal to 0. Therefore, 3y plus 0 into x plus 4 is equal to 0. I'll bring the 4 on the right hand side. So what do I get? 3y plus 0 into x is equal to minus 4. Now let's substitute different values for x and see what we get as an answer. If I substitute, let's say x is equal to 1, what do I get? Oh, we'll start with the traditional method, x is equal to 0. I get 3y plus 0 into 0 is equal to minus 4. So 3y plus 0 is equal to minus 4. Therefore, 3y is equal to minus 4 and y is equal to minus 4 upon 3. Let's take for x is equal to 1. What do I get? 3y plus 0 into 1 is equal to minus 4. So 3y plus 0 is equal to minus 4. 3y is equal to minus 4 and y is equal to minus 4 upon 3. So my solution here and here is the same. Let's try for another number. I'll say let x be equal to minus 3. What do I get? 3y plus 0 into minus 3 is equal to 4. So 3y plus 0 is equal to 4. Therefore 3y is equal to 4. Therefore minus 4. This was minus, I'm sorry. Minus 4, minus 4, minus 4. Therefore y is equal to minus 4 upon 3. Therefore, any value of x that you take, either 0, 1 or minus 3, the value of y, you will notice that it is minus 4 upon 3. Therefore, you can just opt for any of these solutions. I will say the two solutions. Let's say I am picking up the second and the last one. So, the solutions are 1 comma minus 4 upon 3 and minus 3 comma minus 4 upon 3. So with this we have learned that there exist infinite solutions to linear equations in two variables. So we have done with the solved examples. We will take a look at the second exercise of your chapter in the next class. Thank you.
Hope this video increased your knowledge. For more such videos and a completely free educational content, log on to www.epathshala.org or visit our ePathshala YouTube channel. We have each and every question solved for maths, physics, chemistry and biology. So subscribe our channel, share with your friends, like our Facebook page and follow our Twitter handle for regular updates and important educational tips, and also win ePathshala goodies. So what are you waiting for? Subscribe this channel and enjoy the freedom of education.